Right, it's time to do another Fab Life video because Chris deletes comments. Anyway, this is where he's making a lathe dog. Let's get on with it. Tell you what, before we get on with it, let's set him to 1.5 times. And I do wish he'd stop recording in 60 frames a second. It's absolutely fucking pointless and grinds everybody's machines into the dirt, which is why we're doing this in 720. Right, that's the setup for it. So in 2.5 years using this lathe, he's never turned between centres, shut up telephone, and he has never used his faceplate. Yeah. And he has ruined the tip of his lathe dog, of his dead centre. So there is a section of him taking stuff off, putting stuff on. It takes 2 minutes and we learn nothing, so let's go forwards. In fact, it takes nearly 3 minutes. This is billet grade 6061. No, it's a billet of 6061, Chris, you tool. Yeah, it's going to be a bit soft, but hey, you know, no big deal. Yeah, come on, we don't need to see you undoing it. No, that's a reasonable way to cut it. It's not the way I'd have gone about getting that particular chunk of aluminium, but that's the big chunk of aluminium he's got. So yeah, slicing a lump off the end of it, perfectly reasonable. Do it in your bandsaw. Right, if it's stalling the blade, you've probably got teeth which are too fine. But yeah, slowing it down, that'll cut. It's fine. It'll do it in the end, wouldn't it? It's not like you're being paid by the hour. You're being paid by the video. Yeah, we don't need to watch that or that. Okay. There you go. Right. What's the best way of training up the cut of steel? Well, hang on. Let him carry on. Right. Okay. I wouldn't use a fly cutter. There you go. You should have something in between the jaws and the piece here to hold it, because you don't have a reference surface. But you definitely shouldn't be using a fly cutter. If you take deep cuts with a fly cutter, you're putting all sorts of shock loading through your machine, through your spindle, through your bearings, especially your fly cutter is very long, it's over long. In terms of Z height, every time that interrupted cut happens, it's putting shocks through your bearings, it's putting shocks through your spindles, it's driving your machine wild, it's trying to twist the head off the top. You should be using an end mill, or maybe you call the boys at Vivor and get them to send you a shell mill. A shell mill would be the way to go for this. But otherwise, how you go about doing it is up to you, as long as you follow a technique. Yeah. Fly cut. So those are some pretty deep cuts. Those are at least 1 millimetre. Yeah, that's especially with a piece that's up that high in the vise, it's going to sing, it's going to vibrate. Yeah. Let's see what we get to. I've got some brushing of the vise. Do the other side, presumably. Oh no, this time Okay, he's going to get two approximately parallel faces, but the way that you're supposed to do it is put the face that you've just cut against the back end of the vise. So in fact your technique is also wrong, but hey, never mind. Right, now you've got two roughly parallel faces. You're going to chuck it in between the jaws on some parallels and fly cut the whole thing in one go, right? Wrong. So his fly cutter could go out a little bit further and do the whole thing in one pass. That would be great. Also, his head is totally out of tram. You can see that this section here has been cut by the leading edge, and it's then being recut by the trailing edge by quite a lot. So in fact his piece is going to be all wavy like that. It's going to wave, wave. But yeah, he's only making a lathe dog. It's not particularly critical. So he's going to flatten this out, do the other side. All right, we'll let him get on with that. Yeah, you can see how deep that's cutting on the front edge there. And again, those are deep cuts for a fly cutter. Okay, well that's an interesting approach. Presumably he's making templates in CAD and then printing them out. The problem with that is that stuff that's 3D printed shrinks. There is shrinkage, so there is a percentage difference between your CAD drawing and your 3D printed part. He said he's going to trace around it. Okay, he's got his blue out. I'm guessing he's going to miss all his lines anyway. Now, yeah, if you're looking for something that's got a critical size, that's a really bad idea. If it's not critical like this, then yeah, fine. He's going to show us bluing the entire surface, isn't he? Yes. Thank you, Chris. Right, we've wasted an awful lot of time printing that out. You could have done it a third the depth, so you've wasted a lot of time and material printing that, to be honest, if you're just going to use it to trace around. Also, your chunk of aluminium here, you could have cut down to size. That would have been an awful lot less facing. Okay, he's clamping it down to trace round though, that's good. And mostly only tracing once, apart from where he's traced everything twice. Right, you don't get shrinkage when you print, however, so if you're going to use this to centre punch, it's going to be off from your markings, and if it's on stickable vinyl, you're just going to stick it down on your blue. Why have you bothered bluing and tracing? You might as well just follow the lines of the vinyl. No? Fuck me, Chris, you want to use some hand cream and avoid stabbing yourself in the thumb. But your hands look rough. Oh yes, we are. We're going to stick it over the thing that we've just done. How sure are you that that's accurate? Ah, not at all. Yes, super. Right, okay, so that's approximately put down. Again, this is, it's non-critical, so, who cares? Alright, center pop. Yeah, he's putting center pops on the end of the slot. Yeah, not such a bad idea, I guess. Alright, big bandsaw, yeah. Cut around the outside. Now this is a good idea. You cut off as much material as possible with the bandsaw. It means you've got less stuff that you need to machine, which does beg the question of why you bothered squaring these edges that you're going to cut off. Another thing that you did wrong in your squaring up. It's utterly pointless, wasted time. You got bored. All right, okay, good man. Still, this is a reasonable approach as well. Using a horizontal bandsaw to do this, you do need to be a bit careful. If you slip, you're going to chop your piece in half. What might be worth doing if you're going to do this a lot would be to get a cheap laser liner module off of AliExpress, glue it on here so that you can see where your blade's going to go. That way you can set work up nicely in the vise. Those vices don't like gripping on the edge though, and in fact, yes, he's put another piece in the backside there. Good man. Okay, he has learnt something. So that piece of offcut there is just there to keep his vice square. Good man, Chris. Well done. Well, I wouldn't say it's creative, but right, there you go. You see, you're offline. A laser liner would have done that for you, see? But otherwise, yeah, this is a good idea. Take everything off that you don't need. A saw is the fastest way to remove material. Next one's a drill. Which does make me wonder why he hasn't removed the rest. Right, removing the vise. Okay, you can do this on the surface of the table. That could be interesting. Oh, come on. Yeah, cleany, cleany, clean. Right, wipe off the shit, and then wipe some chips back on it with your chippy brush. Rotary table. Good. Right, so rotary table. That's not a bad way of doing this. What you want to do is poke a hole through the middle of this and drill and ream it to the size of the centre pin. There's a centre pinhole on every rotary table. That way you can accurately locate the centre of this piece on the centre of the rotary table without piss-arsing about. At that point, you set your rotary table to 0. You use your centre finder to find the centre of these two and align them with the X of the table, and that way you have a reference set. Then clamp everything down. You will be needing to move clamps as you go, but you can do the whole of the outside by rotating with the rotary table and just moving in Y to get your different distances from the centre. So the distance from here to the centre and the distance from here to the centre are the same. The only difference is the angle, which is here and which is here, which should be the same. So you can cut here, assuming that that's aligned with X, and then you rotate round the other way and you cut this side. Again, you don't need to move in Y and you've got identical cuts. You can do the same on these two faces and do the same on these two faces. At that point, you can do the angles around here by rotating the rotary table, because I'm guessing that these distances, that arc there is part of a circle that goes around. This circle is concentric with it. Then you can do your slot, and then you move the whole thing onto the face plate on the lathe and bore it out, or you can just leave it clamped on the rotary table. Do that with the rotary table. Again, you can do those angles with the rotary table again to get them absolutely bang on. I'd have put a hole at the end here as well, so that you've got as little as possible that you need to do with a file. But you can do the whole thing on. Actually, yeah, you can do the whole thing on the rotary table with minimal pissing about and get a really good result, hopefully. That, however, is incredibly dangerous. Poking a hole into a piece of work, you've never had it helicopter, have you? As soon as that breaks through, there is a risk that it will snatch, And if it snatches, your hands will not stop it. And that bit will spin round and it will whack you in the knuckles until your hands are bloody. It will also bend or snap your drill, and it might actually bend your quill. Ask me how I know. In my case, it was actually in a vise. It swung the vise around as well. Yeah, that makes me pucker. Now, I'm sure it didn't for Chris, because he didn't title this video "How I Ruined My Hands by Being a Stupid Twat." But there you go. Chris makes a lot of mistakes that he doesn't see, and that is one of them. That you can kind of get around it by putting a T-bolt, a T-nut and a bolt in here to stop things spinning, but it won't stop it lifting the part, spinning it round, throwing everything off the table. It's really, really, really dangerous. Learn to clamp, Chris. Ah, okay. So you don't really know what you're doing. That's fair enough. And no, you don't know what you're doing. You're not set up square. You're clamped, all sorts of weirdness. Okay. Now the reason it's clamped all sorts of weirdness is because he's using the T-nut hole here, but that means that his DRO slides are in the way of the handle. Yeah, that's a problem. That's a problem, Chris. You need to fix that one way or another. It's only the covers for the DROs. You could take the covers off while you're using this eventually. Oh, what have I done? Back to, where were we? So, his first time using the DRO. Right. Hole saws are dead cheap. A hole saw would take out quite a lot of that material really fast. Doesn't matter. Don't have an adjustable boring bar, you do have a lathe. You could bolt it onto the faceplate of the lathe, centered up, and just bore it out on the lathe. But then you've still got this, this V bit to do. So, hey, doing it on the rotary table is a good option. I wouldn't have it sat on that big piece of aluminium as a sacrificial part, though. For starters, you're not sure that it's absolutely parallel, because your squaring up was not fabulous, because it's obviously the cut-off. But it's a big chunk of aluminium to be sacrificing. Here's a piece of wood, piece of plywood. It's only so to stop you drilling into your rotary table. And you need more clamps, more than 2 clamps. 2 clamps, not enough, especially not down here. That's all going to wave around. That is a 4-flute end mill. It's not made for plunge cutting. You can get away with it because it's got a hole. Should be using a slot drill or 2-flute end mill, which are made to plunge. That way, because what he's going to have to do here is come in and mill all the way out. With a slot drill, you go in close to the edge and just take the whole chunk out rotary. But you should be doing the outside first. That moved there. You heard it squeak. Let's go back and let's go to normal speed. No, we're on 720. Hang on. Playback speed. That was the one. 1. There we go. Are we in 720? No, oh God, it's put me in 144. Don't do that. Okay. Are we still in normal speed now? There you go. At the point that started squeaking, which is the point where he broke through his part, that moved. That's because you don't have enough clamps. You're not clamped down tight enough, and because it didn't look to be the rotary table that moved. It was definitely the part, I think. Let's go back. Might have been the rotary table. Maybe he hasn't clamped the rotary table down. But yeah, it moved. That's not good. Yeah, it gets all gummy, doesn't it, on a 4 flute? Oh God, we're going to watch him do this whole thing, aren't we? Ah, your vinyl's coming off, all right. You peel off all the vinyl. You've now got lines, all right. Listen to that vibration. Lovely. Not only is it a 4 flute, it's not even a very sharp one. So we're going round and round and round. However, we are doing conventional milling. This is good because his machine is not really stable enough to do climb milling. But this, Chris, is not the reason to own a rotary table, really. Oh, okay, we're climb milling now. Fair enough. Forget I said anything. Now you can see on the sides here the points where he's stopped. That's because as he's rotating, he's loading the end mill. The whole machine is moving. Everything flexes, and as soon as he stops, that loading comes off and it springs back. And it springs back. It does that. That's why this isn't really the best way of doing it. You're going to end up with a dog shit finish. Unless your final pass is incredibly fine. So you can see a really good one just there and just there. And those are done on his final pass as he stops. He stops to vacuum the chips out. Yeah. Sorry, Chris, that's a pretty poor result, but never mind. And he'll have one here as well. Right. That quite clearly doesn't line up. You're flexing your machine to drive that through there. It's slightly off this end, which is an idea of how rigid these machines are. That's your quill movement. Oh, Chris, that's a 10mm end mill. You're going to end up with an 11mm slot, or 10.5, something like that, and it'll be all on the piss at one end. Because as you go in, it's going to pull off. And then when you stop at the other end, it's going to go off the other way. Or maybe the same way, who knows. If you do this with an 8mm end mill, you can go in, an 8mm slot drill in fact would be a far better option because it is after all a slot. You go in, you mill your actual slot, and then you come in and do your final clean-up pass around the outside, like the Buffalo Girls. You do that in one go on each side, tiny cuts, and you end up with something which is 2-dimension. This will be way off of dimension and way off of centre probably. Oh, now you can hear that singing because, again, not enough clamping. This end is pretty much free to do what it wants. Oh, and it's moving. Your inexperience always comes into play, Chris, and it always ruins the part. Oh, good boy. Okay, so it kicked sideways as well. It wouldn't have saved you, Chris. Although actually an 8mm slot drill might have done because it wouldn't have moved enough for you to go outside of your lines. So you're going to have a big fucking guff at the end, aren't you? Yeah, it doesn't matter. But hey. Oh, nice. Look at that. Super. and we're going to see some spectacular surface finish on the inside of that slot. But there you go. Chewy chewy.
Because I had the part set up parallel with the movement of the table, I thought I'd try my luck with machining this portion of the part. I soon found flipping the
Yeah, this is how you should do it, Chris.
part on its side was a lot easier.
A lot easier, but not the right way of doing it, Chris. This is the right way to do it. You've got it set up in the rotary table. It's centered on the rotary table. You can use the rotary table to get things exact, which is what you're doing here, I would hope. Because if you lock your Y, again, lift up, spin round 180 degrees, you can do this side at exactly the same dimension from the center. That's not what you're going to do though, is it? And that is singing something rotten. You want some extra clamping on that. Right, so he's conventionally milled this side, and he's now going to do this side by climb milling. Still, at least he's off his line for the moment, that's fair enough, but he's doing this by eye, as usual. If only somebody had created precision tools to be able to do things in a precise manner, eh? Oh, and he's overshot his line here as well. Good man. Okay, so it's all going to be off centre. Well done. Oh, and that was good enough. Excellent. So in fact, this one appears to be on the line and appears to stop here. This one is further out from the line. You can see the line here, but goes beyond it at this end. Well done. I think Chris is bored. Right, this is a shit way to do this. Should have done it with the rotary table where he had it set up. If you're not using angle plates to set stuff up, you're absolutely bollocksed. You could do this by putting a piece of 40mm stock through your 40mm hole, laying that on top of the vice jaws, and then doing this to distance by locking your Z. You'd have not much less clamped in the vice to do it. That would be one way of doing it. That's the way I'd have to do it because I don't have a rotary table, but I'd be doing it on like a 6mm hole in the middle. And you could do this side and this side, and in fact you could have done the outsides of the slots, but just doing it like this, way up in the air, out of the vice. Yeah, no, Chris, that's pretty awful.
After I'd roughed this portion in, I quickly rounded over the edges.
Yeah, it's all rough, isn't it? Again, like I said, you could have rounded those edges in the rotary table, but that would leave you with just a little bit to do here, which would be a 2-second job on your sandy machine, or pull out a file just to take the edges off.
Over on my bench sander.
You'll notice he's not showing how he's setting this up. I'm guessing it's a parallel of some description that he's laying on here and lining it up by eye, which is, yeah, kind of it's a functional way of doing things, but you know, you had stuff set up in the rotary table, you could have been exact. Right, he's rounded those edges off. He's taken an awful lot off the edges with the bench sander. That's an awful lot of work that we didn't see, isn't it? Because look, all of that shit there, that's all come off with the bench sander. Could have milled most of it off, or in fact sawn it off when you were sawing stuff to bits, but there you go. So, what are we doing here? Right, we're plunging in. Again, these edges could and should have been done with the rotary table. It would have been a good idea to drill a hole at the end here to run up to give you less stuff that you're going to have to file at the end. It's left a lot of meat on there to file off. And that actually is a slot drill. Fabulous. So he's used a 4-flute to do the stuff that you should have used a slot drill for, and then he's used a slot drill to do stuff that you could have used a 4-flute for. Yeah, well done. Oh, Chris filing. Oh dear. Right, well that's the wrong file for a start. You want a triangular file in there because you're going into an angle. Even if it's a 90-degree angle, you want to go in with a triangular file so that you only hit one side at a time, and you don't file with both hands on one side. You're putting all your weight on this edge. It's all going to be out of whack and on the piss. It's going to take you forever, and you'll get a horrible result. Filing always takes forever, but it's nice if you get a good result. That was terrible. Oh, right. Ah, there we go. So, this is the way you should do it. He's loading both sides of the file. He's using a triangular file. That's a far better approach. However, going backwards and forwards is not the right way. He should be going diagonally. Learning to file would be a good thing, Chris, and chalking your files is also a very good idea if you're working with aluminium, because if you use just normal blackboard chalk on your file, stops it gumming up. And don't put both hands on the end like that, because it's just, yeah. Right, okay, well you've missed your angles, you've gone too far here and here. Oh, he's got a rotary chamfering tool, that's nice. That's a good idea. It stops you having those enormous fucking chamfers that you put on the last one. However, that bearing will not go all the way to that angle there, which means you're going to have to chamfer that by hand. It's no big deal, but that's a good tool, that is. I wouldn't hold it in the vise like so though, because you're gripping here on the bit that's got nothing holding it. It'll bend, it'll twist, the whole thing will twist if you put any weight on it. There you go. You want a bigger compressor to drive that as well, Chris, because that was having trouble. Of course there will. Can't miss an opportunity to whore. But no, that's a good tool. Doesn't look like you've filed down into the corners yet, but yeah, that's a good tool. That very much does not look like it's on centre. I'm sure that's not on centre. That looks like it's off by 0.5 mil. Might be an optical illusion, but that really doesn't look like it's on set. No, that's not. That's never on centre. Just a little kiss. There you go. Done. Oh no. No, not done. Do more. Okay. Not more. That's quite a big chamfer. Chris likes his big chamfers, doesn't he? Well, what did you take it out for? You need to tap it. Tap it now while it's in the vise. Hang on, is this a continuity error? Let's have a look. Let's go back. Has that been tapped? Don't know. Because it's back in the vise now to be tapped. Yes. That might have been a continuity error, eh? Because that looks bang on centre. So yeah, I'm guessing that was just a continuity error. But yeah, that's not on centre. I'm sure that's not on centre. Doesn't matter, but you know.
Finally, we are on the home stretch. I now need to make the bar that will rest in the faceplate to prevent the workpiece slipping on the dead centre.
Okay, so what are you going to do? Centre it, mill a flat, tap, yeah? Centre pop, centre pop. Hang on, why am I back on 1 speed? I should be at 1.5. Yeah, I thought I was getting bored. Oh, that's a dog shit finish. You want to go faster? Ah, much better. Carbide likes speed, Chris. Yeah, you're not cutting deep enough or fast enough, Chris. This is what happens when you're afraid of your lathe and you know that you're going to crash it. So he's cutting up to a shoulder. I think he's making a mistake here because that looks like a shoulder that's going to butt against the front of the dog, the back of the dog, and this bit will go through the dog with a threaded bit on the end by the looks of it. You shouldn't be turning this bit down, Chris. You should make 2 flats on it to fit the slot. Makes it an awful lot easier to tighten up the nut that you put on this end. Yeah. So after all that effort to get a decent finish on this, he's going to take it all away, is he? We've got a dog shit finish on there. Mind you, most of that's going to be dyed away to a thread, but because I'm assuming that's 10. What are you doing? Probably M8 here, I guess. And I don't know what size that's going to go to. That'll go to the size of the slots in his faceplate, I guess. Oh, you're doing that wrong, Chris. Now you've got your tool at an angle because you can't get in there. What you should be doing at the moment is you should have taken that off there, cut it off, bandsaw it off, chuck it in your 6 jaw, which is made for taking stuff which is concentric, centre pop the other end, and do it straight from the end with your tool set properly. That way you can run faster, you can run with your tool at the right angle so that you get a decent finish. Or you could take the left-hand tool that's in your fly cutter and cut it from the other end up to this edge. So you could do a bit of a slot in the middle, go one way and then the other way with a left-hand tool. That would be another way of doing it, but the way I'd do it would be, I do with collets, but you've got a 6-jaw chuck, take it out, spin it round, centre pop, bish bosh, job done. Oh, look at that finish. Tasty. That's the kind of finish you get when you use your tools wrong. Right, okay, it's going to do this for the die. Oh no, looks like it is M10. Okay. Okay, M10, yeah, I suppose 17mm. Yeah, that's fair enough, isn't it? I'm guessing that's mild steel by the horrible finish she's getting from it anyway. Yeah. Could have done it all in your groovy 6-jaw, Chris. Oh yeah, that's nice, isn't it? And the finish in there is good. Hang on. I'm going to go back frame by frame because Chris is moving stuff around very, very fast, so we can't see what's going on. Right, he hasn't filed here. He has polished it, not very well. So he hasn't filed here. These are not lined up, so it's not symmetrical. This side is, I think, thicker than this side. Obviously his slot is off dimension, and I'm fairly sure that hole's off centre. It doesn't matter. Like I said, he's got horrible finish on pretty much all of the... Yeah, look at the state of that. That's fucking horrible, Chris. Oh, so you were bored. M8 bolt's fine, but that's not an excuse, Chris. You say, I just used an M8 bolt on the end. That's just, I'm lazy and I was bored. No, you need a drill and a hacksaw and a file. Anything else is extra. Fuck me, that is so far off being symmetrical, it's not funny. Lordy. Now that's where the error is. That needed to be a flat, because otherwise this is, as soon as you start tightening this up, this bar will rotate and you've got nothing to grip it with. So you either needed spanner flats on this part, or just flats so that it locks. You make it with flats so that it locks in the groove. Oh, there's one other thing that you should do as well, Chris. Because you're the man who managed to crash his lathe twice in one video. You should paint the ends of it red. Because once it's spinning, you can't see it and it's a lot wider than the part. Paint it red so that you can see it. Because otherwise, it's either your lathe that's going to bite it, the tool that's going to bite it, or it'll bite one of your hands. And if it bites one of your hands, it'll rip your fucking fingers off. Seen accidents with lathe dogs. It's not pretty. Oh, I'm seeing another problem here as well. Okay. He's made it too small. Yeah. That is borderline too small for that piece of stock. What do I mean by it's borderline too small for that piece of stock? That's a piece of at least 20mm stock. And if we go back, you'll see that he's got his drive bar right at the end of the hole here, and it is almost, come on, finish tightening up with your snap-on. It is almost at the end of the slot. So this part of the slot serves no purpose whatsoever, because you'll never be there with any stock that you can get in here. But anything smaller than this is going to be too short to fit in those slots. Now, it doesn't mean that you can't use it driving against a chuck, using the chuck jaws, but yeah, it's not even the right size, Chris. Well done. Well done. Because in fact, that should be very close to the centre, and that should be basically the width of your faceplate, pretty much. Yeah, cracking. Now, and I have to know, is that a snap-on spanner? Let's go back. No, I don't think it is it? Looks like it's like a fake. Anyway, there you go. That's Chris's latest job. But yes, you want that in there, all that bit there, painted a very bright colour so that you can see it, because otherwise you'll lose a finger. Because as soon as it starts spinning, what happens? You can't see it anymore. Yes, Chris. No, I wouldn't call that a success. I'd call that a borderline failure. Not quite as much of a failure as some other stuff that you've done, but it's about as good as your V-blocks. Great.